Hello, my name is Lane, and for my second video topic covering metals, I've decided to go with lithium, and in this PowerPoint I will be going over what lithium is and how it is used in the engineering world, including a finished product and also some manufacturing processes for lithium in general. Lithium itself is known as Li in the periodic table. It is a soft silvery white alkali metal. It is also the most least dense metal and least dense solid element in the periodic table. Lithium itself is highly reactive and flammable and has a melting point of 356.9 degrees Fahrenheit. Um, One of the sources of lithium, brine deposits. One type is saline brines, which are underground reservoirs of highly concentrated salt solutions. Most prominent of these are found in Lithium Triangle of South America. Those three places kind of originating of Argentina, Bolivia, and Chile. Beyond the Lithium Triangle, other brine deposits are being explored and developed in China, the United States, and Australia. The Atacama Desert in Chile boasts the world's largest active lithium brine operation, known for its high lithium concentration and relatively low extraction costs. Um, One of the traditional methods of brine extraction involves solar evaporation. This image here in the bottom right corner of the slide um, is essentially just like a pool, a reservoir of the evaporation method they use to extract the lithium from the brines. Overall, it is lithium-rich brine is pumped into large evaporation ponds. Sunlight then gradually evaporates water over a 13 to 24-month period, which concentrates the lithium salts. The concentrated solution is treated to remove impurities like magnesium, calcium, boron, and then you have another type of traditional method, which is called hard rock mining. It is essentially lithium bearing ores are extracted, crushed, and chemically processed. There are some challenges that do arise with the traditional method of solar evaporation. Some of those challenges include high water consumption, anywhere from 118,000 to 210,000 gallons per ton of lithium carbonate are being used. It does cause a large land footprint, approximately 903 acres per 1,000 tons. And some of the challenges that come across hard rock mining is that it is energy intensive and generates a good amount of chemical waste. So these traditional methods do overall plant a large footprint and can environmentally be a little hazardous. Another source of lithium, kind of how they get it, is the pegmatite ores, coarse grained igneous rocks that can contain significant concentrations of lithium bearing minerals, most notably spodumene and petalite. Australia is the world's leading producer of lithium from hard rock deposits. And also Canada possesses significant spodumene resources with active mines and ongoing exploration. The Greenbushes mine in Australia is the world's largest and highest grade hard rock lithium mine, which produces spodumene concentrate that is processed into lithium chemicals. Hectorite clay deposits also represent a potentially significant future source of lithium. Some of these deposits are typically found in volcanic regions, in which Nevada hosts significant hectorite clay deposits, and there are several projects underway to develop economically viable extraction methods so that these kind of forms and methods aren't as hazardous as some of the previous traditional methods discussed. Um, One of the newer methods that they have, direct lithium extraction DLE. It is an innovative method for selectively extracting lithium-formed brine sources. It offers a more efficient and environmentally friendly alternative to traditional extraction methods. Two different types of DLE. You have absorption based, which captures lithium ions by absorbing them onto the surface of the selective sorbent material. Then it strips away from the material using chemicals or water, allowing for efficient recovery from the brines. And then the other type you have is ion exchange based DLE, which the lithium ions are exchanged for other cations within the structure of the sorbent material. In which this method requires an acid solution to both recover and strip the lithium, which makes it effective for the brines when they're complex and the concentrations high of various ions. Solvent extraction would also be another key method of DLE. This trying to think of the word, just escaped my mind. This little diagram over here kind of breaks down how DLE is kind of ran. So you'll have the first step here. The lithium rich brine is pumped from deep underground. Then it'll run and the lithium is removed from the brine using the DLE extraction technology itself, and any leftover brine is then re-injected back into the reservoir. But overall, yeah, this technique involves transferring the lithium ions from the brine into an organic liquid phase containing a specialized extractant. Some major advantages of DLE include the increased production when extracting, addressing the growing demand for lithium and battery production. So being able to extract it faster with technology kind of expanding, and obviously the need for lithium ion batteries, especially in electric vehicles, and just kind of as time overall and technology expands, the need for these things is going to be more. Which kind of just gets right into the final product that I was going to discuss, which was the lithium ion battery. It was initially introduced commercially in 1991. The batteries themselves have revolutionized portable electronics, electric vehicles, and grid scale energy storage, and they could be highly energy density, have a lot of high energy density, long life cycle, and fast charging capabilities. They're an extremely vital and important product. They're rechargeable, and just so many different uses of them, especially like I've said, the electric vehicles, that kind of portion of it is only going to become more and more important as time goes on. And then this here will be all my references, and we're excited.